Hey guys, so today's Leak Code Daily Challenge I was not able to do. Um, yeah, I just struggled with it. Um, like partway through I was like, or after reading it, I knew we needed to use like obviously some like math or maybe some cool power of three trick, but yeah, I wasn't able to come up with a solution, so I had to look at the answer. And it's actually not bad now that I think about it, but I think you have to know certain things about base 3 or like base 2 or base 10 numbers, right? Like they're all the same kind of. So if we just so that we're all on the same page, like take this number 123. In base 10, what does that mean, right? Well, this is like how many to the 0, 10 to the 0, 10 to the 1, 10 to the 2, right? That means 10 to the 2 plus, um, oh, sorry. Yeah, plus, actually, let me write this a little bit better. This means 10 to the 2 plus 10 to the 1 plus 10 to the 3, 10 to the 0. Sorry about this. And then these numbers right here, they represent how many times that happens, right? So this will happen one time. This would happen two times. So 2 times 10 to the 1. And then this one here would happen 3 times. So it's 3 times 10 to the 0. Now, if we like do all of this, we see that this is 100 plus 20 plus a 3, right? Which gives us 123. Actually, furthermore, we could see that if we had a number like 1, 2, 3, if we were to just mod by 10, right? If we mod by 10, it will give us the last digit. And then if we divide it by 10, right? If we divide it by 10, then it would give us the remaining. Like we could just take off the 3 because we're done processing it, and then it would just give us 1, 2. Like basically 123 divided by 10 is just 12, right? So with that being said, we could do something very similar with like a base 3 number, and a base 3 number wouldn't have a 3 in it, right? Like let's just say it was like 1, 2, 0. All we would have to do is mod 3 to just get the last digit, and then we would divide it by 3 to get the remaining. So if it was a base 10 number, because they're going to give us a base 10, right? If they gave us a base 10 number of 12, if we want the first digit, all we have to do is mod it by 3, right? So 12 mod 3 is 0. I don't know, wait, 12 mod 3 is 0. So we're going to have a 0 right here. And then we also want to divide by 3 to get the remaining like thing after processing, because we already processed that digit. So 12 divided by 3 is 4. So now we're on 4, right? So we could do the same thing. 4 mod 3. 4 mod 3 gives us 1. And let me just make sure. 4 mod 3 gives us 1, right? So we're going to have a 1 right here. And then we can divide it by 3. So then we could do 4 divided by 3, which also gives us 1. Cool. And then we're almost done, right? Now we take this 1 right here and do mod 3 again. We get a 0. Let me just make sure. 1 mod 3. No. 1 mod 3 is a 1. And then when we do 1 divided by 3, now we get a 0. And then I think we're done here, right? So something to realize is that if we ever ran into a 2, then we know that we're wrong, or like that we should return false. And the reason why is, let's just take this number 2 for example. So now we're going to do 2 mod 3, and that's actually going to give us 2. And what does that mean? That means we're going to do 2 times 3 to the something, and in this case it's 3 to the 0 because we're on the like 0th iteration, right? Like we just started this, and that will give us 2. And since this problem says distinct powers of 3, if we ever mod something and it becomes a 2, we know that we're in trouble, because that means we have to multiply 3 by some random number. It could be 3 to the 0. We know we have to do it 2 times. So that breaks the distinct. And so for like base 3 things, there's only like 3 things that we're expecting, right? When we mod by 3, we're expecting a 0, 1, and 2. So in this case, 0 means that it's going to be multiplied 0 times, which basically means we're not using the current number, right? So 0 just means like not use, like we're not going to use it. 1 means we're going to use 1 times, and then 2 just means use it 2 times, right? So if we ever see, like I said, if we ever see a 2 right here, we know that we should return false. Yeah, so that's kind of tricky to me. I guess it's something that you need to realize, I guess, because I think we could all agree that if we were given, I guess we could all understand that if we were given like a base 10 number of 123, we understand that that's like 1 times 10 to the 2 plus 2 times 10 to the 1 plus 3 times 10 to the 0, right? Like we understand this, but then now that we're working with base 3, it's going to be a little bit different. So what we need is just while n, I guess while n, right? Because our n case is when n reaches 0. So while n, if n mod 3 is equal to, wait, what? Oh yeah, if n mod 3 is equal to 2, that means we are going to have to use that power twice, which means it's not distinct anymore, so we just return false. Otherwise, we should already process that last digit. So now let's like shrink our number by dividing it by 3. And in base 10, when we divide it by 10, we're just removing it right here, and now we're just dealing with 12. Similar idea, we're just divided by 3, now we just deal with whatever's left. Then we could return true at the end. Cool. Yeah, I was kind of sad about this problem, not happy about it. I had to look at the solution, but I guess, yeah, it's just something we need to realize with like number and math in base 10, base 2, base 3, like how they work. Earlier on, I was doing some pretty whack stuff. I was thinking about maybe using some sort of backtracking, and it did work. Like it was able to pass all of these test cases, but for me, or what ended up happening was it was just time limit exceeded. I guess backtracking, right? Like we're just trying every single combination to see if it works, and that just ended up just taking way too much time. So obviously the best solution is a linear solution like this. Actually, this isn't linear. We're dividing, we're shrinking it by 3 every time. So it's like a log. It's like a log n, but like log base 3 of n, I think. Let me look. Yeah, it's a log base 3 of n, because I guess whenever people say log n, that's implied log base 2 of n, right? But this is log 3 of n. Log base 3 of n, and then we're not holding any extra space, so it's just O1 constant. But yeah, thanks for watching, and hopefully I can get tomorrow's better. See ya.